Okay, I promised I would give you a shortcut on this proof. So this is number 3, revisited, from your worksheet, and we're going to approach this a different way. So we're going to be using one of the theorems that we haven't used very much, but I told you that it would give you, it's a really good shortcut in a proof if you do learn to use it. So it's worth taking a look at. Setting up my proof, we've got angle 5 and angle 14 are supplementary. And of course I know that L is parallel to M, same given information. So I've got L and M are parallel to each other, and I'm going to focus again on either angle pairs up here or here. And this time, instead of working from the bottom and trying to get to something that's supplementary that will prove lines parallel, I'm going to actually try to make a statement that's very similar to the one we're given, but slightly different, and I'm going to focus on either using 5 or 14. So I think I'm going to use 14, and I'm going to find an angle pair that I know is supplementary to 14 based on the fact that L is parallel to M. And you have a couple options. We could go with 13 and 14, or we could go with 14 and 15 because those are linear pairs. And I'm not going to do that because I don't like 13 and 14 because 13 and 15 because they're not in any relationship with 5 up here. So I'm going to specifically use the fact that L is parallel to M, and I'm going to find my consecutive interior angle pair here. Because L and M are parallel, again, only using the bottom half of my picture, I'm not even using the top there, I know that angle 9 and angle 14 are supplementary. So that's going to be my second statement, and I'm using right there the consecutive interior angle theorem to make that statement. Now what I've done is I've set up a very specific set of statements here in my proof. And I'm going to need you to find your theorem sheet and look for what conclusion we can make if we know this is true. I'm looking for a direct conclusion. And I'm going to rephrase this for you. Instead of looking at that literally and reading all the angles, I want you to notice that we have 2 different angles, angle 5 and 9. So 2 different angles that are supplementary to the same angle, angle 14. If that's true, then what conclusion can we make? Take a look at your theorem sheet, pause the video, and then come back and tell me what you can say. Okay, good. Hopefully you were able to come up with the conclusion that angle 5 is congruent to angle 9. If you're thinking along the lines right now of measure of angle 5 plus measure of angle 14 equals 180 degrees, I absolutely agree with you. That's true. You're using the definition of supplementary angles, and I would refer you to my other video, video 4 that I made, because you're just thinking in a different way, and that's fine. But that video is going to help you out a lot more. If you're able to get angle 5 is congruent to angle 9, I'm assuming you found the correct theorem. It is the congruent supplements theorem, which was number 9 on your blue sheet, your theorem page. So what I just did is I avoided having to say the measure of angle 5 plus measure of angle 14 equals 180 degrees. Same thing for 9 and 14, setting them equal to each other, subtracting out angle 14 to get the measure of angle 5 equals measure of angle 9 to then say they're congruent, which is about 5 or 6 steps that I just rattled off there. Now, this is only good if that helps me in some way. So let's take a look at our picture. How do I know this is going to help me? Well, what kind of angle pair is 5 and 9? Yes, you're right, they're corresponding angles. And the problem is that I couldn't have said they were congruent by my corresponding angles postulate because I have to know lines P and Q are parallel to say 5 and 9 are congruent. But, other way around, if I miraculously somehow know that angle 5 is congruent to angle 9, then I can conclude that P is parallel to Q because I'm using right now my converse postulate of corresponding angles postulate. If the angles are congruent, then I know the lines are parallel. So that makes this step 4, P is parallel to Q, and my reason is corresponding angles postulate converse. Make sure you put the word converse with this. Or you could just write out that if corresponding angles are congruent, then lines are parallel. That's what my converse postulate is saying in condensed form when I use that name. So this proof was 4 steps. I can't remember what the other one was, maybe 8 steps. We definitely cut out some steps by doing this, maybe 7 or 8 steps, I can't remember. So if you can follow that, really great way to do this proof. If not, check out video number 4 that I made, and that might help you out. You might like that way better.